Now we're ready to talk about our fourth type of reaction known as double replacement reactions. These involve two compounds dissolved in water, so they need to be aqueous, so that they will dissociate into their ions. In other words, they dissolve and break down into ions when they're in water. The cations will switch places with each other, so that each anion is now paired with a new cation, and in the process, a precipitate will form. That means a solid will come out of the solution as this reaction occurs. Their basic reaction formula is AX plus BY makes AY plus BX. So you will notice that the anions are now with new cations. This clip shows the double replacement reaction of sodium phosphate with iron 3 chloride. We can see in the end what we have made is sodium chloride formula unit to go with our iron 3 phosphate formula unit. If we watch it again, it becomes more apparent. You can see them breaking apart, swapping partners. Iron's now with phosphate, sodium is now with chlorine. Another example of a double replacement reaction is when silver nitrate and sodium chloride react in solution. Notice we have Ag with NO3, but in the products we have Ag with Cl. In the reactants we have Na with Cl, but we have in the products Na with NO3, so they have swapped partners. Note that the cations in the reactant switch anions, resulting in the formation of two new compounds. Combustion reactions are the fifth and final type of reaction that we're going to look at. They can be generally defined as reactions in which an element or a compound reacts with oxygen, producing energy in a form of heat and light. Now, they can be recognized by the basic reaction formula of fuel plus oxygen makes products plus heat, because heat is given off. These are exothermic. This animation shows the reaction of hydrogen gas, shown on the right side, with oxygen gas shown on the left. These are both diatomic molecules, as you can see, and as they come together, they are ignited, and just a little spark is enough to get the reaction going, and then it continues because a lot of heat and light energy gets given off as the product is made. And as you can see, the product here is just water. So hydrogen burns to form just water as a product, which is why hydrogen fuel is considered the cleanest fuel there is. Many combustion reactions involve hydrocarbons that burn completely in oxygen to yield water and carbon dioxide. So the basic formula for those is fuel, that's our hydrocarbon, with oxygen, yields CO2 plus H2O, plus of course heat, because these are also highly exothermic. Now, incomplete combustion can also occur, which would result in the formation of carbon monoxide instead of carbon dioxide, and we'll talk about that a little more later. Here's an example of complete combustion. In this case, we have methane burning in the presence of oxygen. There's always oxygen anytime there's a combustion reaction, always. So we have methane with oxygen, and what gets formed is CO2 and H2O. And you can see that we've mixed together these methane molecules with these oxygen molecules. And what gets produced is this mixture of both water and carbon dioxide molecules. Internal combustion engines also utilize the burning of hydrocarbons to get the energy needed to power your vehicle. Now, here's a little more on incomplete combustion. This occurs if there's not enough oxygen present. So there's limited oxygen. There is oxygen, but it's not present in large quantities. So with incomplete combustion, instead of making CO2 and H2O, CO gets produced, either by itself or a little bit of it along with CO2 and water. Now, that's incomplete combustion, but this can be dangerous to be around if this type of reaction is taking place, because carbon monoxide, when you inhale it, it can bind with the hemoglobin in your blood, and then it's hard for it to get rid of it from the hemoglobin. So your body gets less oxygen carried to all of the cells, and that could lead to death. So we've covered all 5 types of reactions. We'll watch this video on these 5 types of reactions in class on another day.